Okay, let's get going. 3 minutes past the hour. Welcome. My name is Erik Gross. I am your instructor today. This is me with a little less gray in my hair. What are you going to do? So, I'm a senior level software developer. All that means is I've been doing this for a long time, and so I've seen a lot of stuff. I'm a military veteran. I was in the Navy for about 6 years, a long time ago, right? I was a nuclear reactor operator of all things, and an electronics technician and an instructor in the Navy. It does seem like an entire lifetime ago. I got out in 94. If anybody wants to do the math, that means I'm old. And I'm the co-founder of the Tech Academy. More on that later on. But I'll be your instructor today. I'm really glad to see you. And we're going to have a lot of fun today. This is great. Like, people get their hands dirty actually writing code. I love doing this stuff. Now, a couple class rules. Normally, we would have a class assistant. A little bit of emergency on her part tonight. So it's just me all by myself. So I'm going to have to manage everything, but it's fine, right? So I'll be watching chat throughout the whole evening, right? As I can, I'll answer any questions you have in there. And we also have Q&A, towards the end. I rarely have anybody who's a jerk in these classes, but if you're not nice, I'll just boot you, right? These classes are for really bright, awesome, nice people who want to learn to code. A couple things about that. We are going to be writing code tonight, and sometimes it's challenging. You might run into challenges, and part of the learning process is working through those challenges. So use chat as needed. Like I said, I'll be watching it, right? But one of the biggest pieces of advice I can give you is when I write code, I'll try to go, relatively slowly and explain things as I go. But when I write code, make sure that you type the code exactly as I wrote it, exactly as it's written. And the reason for that is that computers are picky. Well, it isn't that computers are picky, it's that computers can't think. And so a misspelled word or a missing symbol or even something capitalized that should be lowercase can result in errors in your code. So when I'm typing out code, just try to type exactly what I type. I don't very often get people on mobile devices for these classes, but if you're on a mobile device, you're not going to be able to do much of the coding. That's real difficult on an iPhone or Android. But you can listen and you can learn a lot. So please do stick around through it. And of course, all these classes are uploaded to YouTube, so you'll be able to watch it later on a desktop or a laptop. One of the biggest things, though, is this. Please make sure you're in a distraction-free environment, right? Some of these concepts are simple. Some of them take a little bit of work, but it's mental work, and you need to have all your wits about you to follow this stuff. As I mentioned, we put these classes up on YouTube. I'll give you links at the end of the class here to where to find all of our free educational resources, including this video when it gets uploaded. Also, you will be given the full code to the computer game we're going to make today. We're going to build a Hangman game, right? And you'll get all the code, and you can mess around with it and learn even more after the class and play the game because it's kind of fun. So please use the chat. If you haven't yet, drop a word in chat and let me know, where are you joining us from? Where are you watching the class from? We've got people from Florida, Canada. I think it's Saskatoon. I hope I pronounced that correctly, Mina. Sonia, you're from Petaluma. I know exactly where Petaluma is. I grew up in Mendocino and Fort Bragg, which is an hour and a half, 2 hours away. That's awesome. Welcome. It's good to see you. Yeah, that's a cool place. I like Petaluma. All right. Okay, good. So here's the basic agenda. We'll have a short explanation of the Tech Academy, who we are, what we do. Then we're going to write code. Get your hands dirty. Like I said, I'll be watching the chat for questions as we go along, but time permitting, we'll also have a brief Q&A session at the end. So don't hesitate to throw a question in chat. If I can answer it right then, I will. If not, we'll try to pick it up when we're done. Then we'll go over some information about our boot camps. There is a free gift at the end. So please stick around until the end, and it's worthwhile. It's a really cool gift. The entire class should take about an hour and a half. So who are we? Who's giving these free classes? Well, we're the Tech Academy, and we've been around a while. I sometimes can't believe it's been 10 years, right? What we deliver is coding boot camps. And if you're not familiar, most people are. Coding boot camps are intensive technology certification programs. It's a new thing in the industry. Prior to about 11 years ago, these didn't even exist. Boot camps are designed to get people ready for entry-level positions in tech fast. Typically, depending upon who's delivering the boot camp, they might last 3 to 6 months, some are longer. And all of them focus on modern, practical skills, the kind of things that employers need. And like I said, 10 years ago, they were a brand new idea. Now they're a pretty standard part of the technology industry. We've been delivering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade now. In February, we had our 10-year anniversary. Our certification programs are cost-effective. They're self-paced, which is kind of cool. More on that later on. They're all online, and they're tailored for beginners, people that have no prior technical or coding knowledge. We teach in-demand skills thoroughly. Our programs are endorsed by stellar online reviews, and they're designed to fit around your personal schedule. We want to prepare you for a technology career with a really well-rounded toolkit. If you're at all familiar with the industry, you probably know this. The average cost of boot camps in America is around $13,500. They can be pretty expensive. Ours are under the national average. We've had boot camps that start as low as $5,300. And I always like to read our mission statement. This is something my co-founder and I, Jack, sat down and put a lot of thought into in late 2013, early 2014, and it's held us in good stead. The mission statement of the Tech Academy is this: to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's what we're here for. Our product is you working in tech. One other thing I want to mention, because it's brand new, it's a new service we launched about a month ago. It's called the Tech Academy Accelerator. This is a monthly subscription program, and it includes live weekly workshops with me. More about that in a second. Over 100 educational videos and over 100 self-paced online mini classes in, highly technical subjects. In fact, these workshops are a deep dive into complex technical subjects. The class you're in tonight is introductory coding. It's a free coding class. In the accelerator, we have people, who've been working in tech brand new or for years, and we cover really deep, nerdy stuff that can help you accelerate your career. It's open chat and voice. We communicate back and forth. We teach topics suggested by the community in the accelerator, and it's super cheap. It's $9.99 a month, and you can do a trial of it for a week just to see if you like it. So if that is something that is of interest to you, I'm going to drop a link in the chat right here. See how well I do this without an assistant. I did it. Okay, good. Yeah, so that link will take you to a real simple form if you want to try out the accelerator for a week. It'll ask for card information, but you don't get charged. I set up the technology on the back end myself. It won't charge for a week, so you have a chance to, log in, check out the community, check out the free training resources, and attend one of our free workshops, so you can see whether or not you like it. Right? So I'll give a minute, take a sip of water if anybody wants to click on that. I'd love to see you in the accelerator. It's a lot of fun. What we've been working through for the last week or two is how do you take a software program that you built on your own computer, maybe as like a tutorial or a learning action or whatever, and you want to put it out for the whole world to see. How do you get your program hosted out on the internet as cheaply as possible so that other people can actually go to it and use it, and you can prove out that you have skills with a real live computer program deployed out on the web. And so we've been working through all the kinks on that. It's a lot of fun. All right, so let's jump into this. If we're going to code, we want to cover a few fundamental terms. Now, if you've been looking into technology at all, some of this will be, familiar to you. Some of it might be the first time. What exactly is a program? Well, it's a series of instructions that you, as a professional, can enter into a computer, and it'll make it do certain things. I know that's a really simplistic explanation, but it's the truth. The big thing here is that where before you might be using someone else's program, like a word processor or a game or some sort of utility, you're using their program. This is different. You get to make those programs by entering these instructions into the computer. You do that by using a programming language. This is what the instructions are made up of. And it's just like a regular human language, except it's got to be very precisely written because, again, computers can't think. And so all it is combinations of words and symbols and phrases, and they allow you to communicate with the computer and tell it what to do. This is the tool you use to make the programs. Coding is the action of entering in those instructions, and code is the instructions themselves. So again, pretty fundamental terms, but I want to make sure we're all speaking the same language. We do need to talk about Python because tonight's program that you're going to work on and all the practical exercises we're going to do are using this computer programming language called Python. It's really popular, and it's been around for a while, actually, like late 1980s. This Dutch programmer, Guido van Rossum, I always have trouble pronouncing his name. Not as bad as what I did to London's name, but I have trouble pronouncing it. He set out to make a language that was really easy and accessible for people to learn, but also really powerful. And he succeeded, right? When you read Python, it resembles common English languages and words, and you can read through and figure out what the program is doing. It's easy for beginners to kind of dive into, but you can build almost anything with it. Full-blown applications, websites, games. Python's very versatile. All right, now pause for a second. Because one, I need water, and two, this slide is super important. So tiny little bit of background, right? Part of the reason that I've been able to succeed to any degree in technology is because from a very, very early age, both before I went in the Navy and then in the Navy, I learned the fundamentals underneath these machines called computers and these things called programs. And because I knew the fundamentals really well, as technology got more and more complex over the decades, it was easy for me to keep up. And in all those years, the data I'm going to lay out on this slide remains some of the most important fundamental information for anyone who writes programs, for anyone who wants to break into technology. So I know I'm setting it up as like a big deal, but it factually is. And what it is this. Any computer program you make is made up of only 5 things. And if you understand what those 5 things are, then your learning journey is a lot easier. And when you get onto the job and you're working with very big, complex computer programs, your ability to understand them and contribute meaningfully to those programs goes through the roof. So these 5 things are actually really important. So what are these 5 elements that are present in any computer program? The first one is an entrance. It's the first instruction, which sounds kind of simple, but it's actually really important. Think about this. You go to a computer and you want to start a program, like you want to start Microsoft Word, or you want to start a game or Excel or whatever program it is, right? When you click on that icon and the program starts, well, your computer needs to know where in that big giant set of instructions that is the program, where does the computer look for the very first instruction? And if you point it to the first instruction, well, the program will say, do that, and then do the next, and then do the next, and then do the next. Now, it does it super fast, but that's all that's happening inside your program. One instruction at a time, right? So why is it important to know where the first one is? The computer needs to, because when you start your program, it needs to know where to start, but you are now on the business end of making programs. So let's say you get a job and you become part of a team that's working on a really, really large program. And you've got to become, first of all, just familiar with what is this program and what does it do and how does it work and what's the logic inside all of these instructions. And one of the best things you can do to start to break that down and just understand what the program's all about is to go to the very first instruction in the program and just start moving forward one step at a time and following along with what are the instructions? What do they do? Why do they do that? What's the order things are done in? If you were to pick an instruction somewhere just randomly in the middle of the program and try to figure out by context what was going on, it'd be a lot more difficult. So this entrance point to a program is actually very practically important. Here's the next core element of a program. And by the way, these elements aren't presented in order. Like when you build a program, you're not necessarily putting all these things in an exact order. You make use of each of these. The next one, though, is what we call variables. Now, this is, again, a pretty simple concept, but it's what makes programs pretty valuable. A variable is something inside your computer program that keeps track of data that can change as the computer program's running. A very simplistic example would be if you have a computer program that's designed to help you keep track of the students at a school, and you're assigning students to a specific class. Well, you probably have certain rules about how many students can go into the class, and so you better keep track of that. Again, I know it's simplistic, but can you imagine if a computer program was built where it couldn't keep track of data that changed? And it couldn't have data change. For example, what if, okay, just gonna be a little bit nerdy here and have fun and imagine. Let's say you designed a school and you said, okay, the class size is going to be 10 people per classroom, and that's it. And you built the program and you made the program set up so you could only have 10 students in class. And then the program is working and you're running the school and everything's hunky-dory until you grow really big and you realize, oh man, we need to have 15 students in the class. You can't. I mean, you physically can. You can put the 15 people in the classroom, but your software was built with this fixed number of students in a class. And you can't change it without going back and rewriting part of the program. And that's not very practical. So again, a silly example I just made up, but I've seen worse things happen in programs. So you need things inside of your computer program that can keep track of data that can change. And those are called variables. Without those, programs are of limited use to humans. Next element of a computer program is control and branching instructions. A lot of the times when we're building computer programs, we're building them to replicate something that people would do manually in the real world. And one of the things we do in business and even in games we play is we make choices. You're playing a video game and you come to a fork in the road and you go right or left. If you are, deciding between two different classes to choose as a student, you're going to choose one of these two different classes. We make choices. Well, our computer programs need to be able to emulate that. And so one of the things that any program needs to make use of is the ability to control whether one of two or more possible sequences of actions gets performed. Those sequences of actions, they're called branches. You can kind of think of it as you start at the top of the program and you're going down and all of a sudden you hit a decision point and now there's two different ways you could go. The instruction to control which way you go is a control instruction. And the different ways you can go are called branches. And they're just separate sets of instructions. And we're going to build all of this tonight. You're going to see these things being used. But I think you can probably see how a computer program that didn't have this capability wouldn't be very valuable. It would just do the same thing each time, top to bottom. It would have no variability, no options. So that's control and branching instructions. And now we come to one of the biggest ones, subprograms. A program will make use of subprograms, or as it says on the slide, programs within programs. And this isn't some silly Inception thing, Leonardo DiCaprio. It's a very practical thing. If you're a programmer and you're writing a big old long program, it's extremely likely that you're going to find that over and over again, you find that there's this a set of certain actions you're taking at various points throughout the program. And they're the same actions every single time. It might be the same 5 steps that you do over and over again at various points in the program. Well, it's extremely valuable to you to be able to take those 5 steps, in my silly example, take these 5 instructions and set them off to the side as what we call a subprogram. Give it a name and say, hey, we're going to call these 5 instructions subprogram A. And it's a fancy name, right? Why is that valuable? Well, a couple of reasons. One is that now on, when you do that, every time you're writing parts of your program out and you need that exact set of 5 things to happen, you don't have to type out all 5 of them and possibly make errors in your coding. Instead, all you have to do is call on subprogram A and say, hey, when you get to this exact point, just go do this subprogram. And when you're done, come back and pick up where you left off. Now, the other really big value there and why this is a core element of a program is this. Let's say in the future, something changes about the way those 5 steps inside that subprogram need to be done. Maybe you need to expand it a little bit, tweak some of the logic inside there, change an instruction a little bit. If those 5 steps weren't packaged up in a little subprogram, what you'd have to do as a programmer is go through your entire program and find every single point where you've done those exact 5 things in a row and make your changes at possibly hundreds of different points. And it would add a lot of time and work that was unnecessary. So a subprogram is a really valuable thing. And then the 5th element. Every computer program needs this. It needs an exit point. It needs an end. Now, why is this valuable? And don't worry, we're going to be coding really soon. Here's why having your computer program have a specific way of ending off is valuable. When you run a program on your computer, there's lots of things down inside the computer that your program needs to be able to work effectively. One of the biggest ones is this. Inside your computer, I'm tapping a tower, computer right next to me. Inside your computer are these little devices called memory devices. And without getting into all the nerdy electronics of how they're constructed and everything, it's enough to know that you can store data inside there. Well, when you're running a computer program, your program works with data. And so that data that your program is working with is going to get stored somewhere in one of those little devices. What would happen if another program on your computer had access to that same location in the memory device and went in and overwrote all of your data? Your program would be screwed. You'd be in trouble. So one of the things your computer does for you when you're running any program is it reserves sections inside those memory devices and says, hey, this whole section in here is all allocated to Microsoft Word, or it's all allocated to Diablo, or whatever you're playing, right? Or whatever you're doing. And no other program is allowed to touch it. I'm sure you can kind of see why that'd be valuable, but what happens when you're done running Microsoft Word or done playing Diablo? You need a way in your program to inform the computer, hey, this program is no longer being run. Any resources that you've allocated towards me, you can free them up for other programs to use. And there are other nuances to it that you'll learn about, as you do more technology training, but that's one of the biggest ones. So I hope you can look at this list and see a little bit of logic there that like any program would need all 5 of these things. And these are really all there is. If you look at any program, no matter how small or how large, it will not have anything besides these 5 elements. That's all that will be inside there. And so knowing these can help you a lot in, like I said, learning to code and then working on more complex programs. All right, now, anybody got any questions? I'm going to pause for a second. Anybody want to drop anything in chat? And then we're going to jump into coding. All right, let's get our hands dirty. So we need a place to enter in our instructions. We need a code editor. So I'm going to grab this link right here, and I want each of you, I'm going to put this in chat. Oh, I did this wrong. There you go. That means that I also put that other link for the accelerator in the wrong place. See, I did need my assistant. All right, so grab that link that says bit.ly/Tech Academy Python. Grab that one, and you should get something that looks like this on the left, or on the right here, okay? You should get a code editor. I'm going to have one up here in a moment too, okay? Once you've opened that up, what I want you to do is make it so that on the right-hand side of your screen, if you've only got one monitor, you've got 2 monitors, you're in heaven, right? If you've got one monitor, then make sure that on the right-hand side is that tab that you just opened up with the code editor. And on the left is me, the Zoom call, because I'm about to switch to my code editor, and that way you'll be able to see my code on the left and your code on the right, and you'll be able to follow along. If you run into a problem, especially sometimes Zoom is not very friendly, if it's not letting you resize Zoom and move it around, you can click on the word Zoom meeting in this little menu here will appear. Click on restore and it'll squash down the size of your Zoom window and you can move it around and resize it. Same thing with a browser. This little symbol in the browser can be used to resize and then reposition the browser. All right, so let's get into coding. Now, this is my code. I think I have, there we go. Anything that's in there you can erase. Whatever code is there, just erase it, all right? The first thing I'm going to do is I'm going to show you the full program. Don't try to follow along yet. I'm just going to show you the full program. This is the Hangman game, right? And as you can see, there's a whole lot of code in here. There's images. Clearly, those are images of Hangman. If you've never played Hangman, I'm not sure what to tell you. You're going to try to guess a word, and if you guess a letter wrong in the word, then some poor fellow is going to hang from the gallows. I know, it's a really negative game. I don't understand why we all played it. And so there's a lot of code in here and everything. Now, by the end of this class, you're going to be able to understand a fair bit of what's going on with the code. And any one of our graduates from our boot camps will be able to understand it and every single line of code here and write programs like this. So there's the program. Let's go ahead and run it. And so I've got to guess a letter here. All right, well, I've played enough of this to know that T is kind of likely. Oh, T is not in the word. Oh, no. I drew my head. How about an R? Nope. How about an E? No. Wow, I'm doing horribly. M. Oh, there's an M. Okay, all right, good. An A? A. An H? I think I see where this is going. An N, a G, and a 1. Okay, good. So that's the game, right? We just want to have some sort of a thing that we can kind of think with as we teach these fundamentals, and that's the game. And again, you'll get the full code to this momentarily, okay? But let's teach Python by using those 5 basic elements. So hold on just a moment. So let's talk about like just the entrance point. Now, for most programming languages, the very first instruction in the file that you're creating is instruction number 1. So we're going to make an instruction here. And all we're going to do is we're going to print something over on the right-hand side of the screen. So in Python, it's a pretty simple instruction. It's just print, all lowercase. Give me a type print, but don't hit space. Because we're about to discuss one of the more basic but important elements of writing computer programs. And here's what it is. Print is an instruction. But print is an instruction that needs information in order to do its job. That's probably pretty implicit and obvious because of the name of the instruction. You're going to print something, you have to have something to print. In most languages, Python included, if an instruction needs information, you give the instruction that information inside of parentheses. So again, without hitting space, I want you to give an open parentheses. Now, you may have noticed you didn't type that closed parentheses. It was automatically generated for you. That's just a helpful function of this code editor we're using. And lots of code editors will do things like that for you. Why? Because if you happen to forget that closing parentheses, the instruction print would have a hard time working because, again, computers can't think. If you didn't have an end, i.e. that closed parentheses, your computer isn't just going to assume what you meant. You have to tell it explicitly what you want. So what do we want inside here? Well, I want some text to display over on the right-hand side here, and I just want my name to appear. So the text is going to be inside of double quotes. So the double quote is to the left of the enter key, but you have to hit shift. You'll notice our code editor also made the matching double quote. Again, because it's a helpful little tool. Your text needs to be inside double quotes, and whatever's inside them is what gets printed. So go ahead and type your name. I'll type Erik because that's my name. And then go ahead and run it. Now, I know this is not like rocket science, but I just want to get you a little familiar with some of these concepts. We have a built-in instruction in Python called print. In order to give this instruction information, we have to put it inside of parentheses. The information we're giving it is text data, and text data needs to be inside of double quotes. And your computer can read through this, read one character at a time, and go P-R-I-N-T. Oh, I know what that instruction is. That's a Python instruction to display something on the screen. Well, the next thing I expect is some information inside of parentheses. So it finds this next parentheses right here, and then it reads forward until it finds the closing parentheses. He says, oh, I found the two parentheses. Now let me look and see what's inside. It says, huh, oh, I found a double quote. Oh, well, I need to go forward until I find a second double quote. Okay, I found it. Oh, I need to grab everything inside of those and print that on the screen. Now, I know I belabored that point, but I did it for a very specific reason. Computers only do one thing at a time, and they do them in very precise order. The creator of Python programmed Python to do exactly what I just laid out. It will see the beginning of a line. It'll read through one character at a time until it recognizes that those characters are an actual instruction inside Python. And then it'll go, okay, now this specific instruction expects for the very next character to be a parentheses. And oh, look, the very next character is a parentheses. All right, no errors so far. And then Python, the program, says, all right, well, what I'm supposed to do next is move forward one character at a time until I find a closing parentheses. I haven't found it. Oh, I found it. Okay, good. All right. And Python says, okay, the next thing I'm supposed to do is go back until right after the opening parentheses. And I'm supposed to find some text. Well, this next character, I found a double quote. Okay, that's the beginning of text. I'm supposed to go forward until I find a second one. Boom, boom, nope, not here. Boom, I found it. Okay, good. And again, that's how tiny the little operations are that are built into this language and any language. That's actually how the computer does it. The computer does not look at this and understand implicitly, oh, I'm supposed to print the word Erik to the screen, because computers can't think. They only operate on patterns. The first pattern is, well, we found this pattern of the letters P-R-I-N-T. And I have a pattern built into Python that says, oh, that's an instruction. So just being able to think in patterns helps you tremendously in terms of working with computers and being a programmer. All right, good. So that's an instruction. Fine. Well, now let's go to the next thing, which is variables. We have our first instruction. It's to print Erik. Let's do a variable. So we have a Hangman game. Now, that Hangman game didn't show the name of the player. I kind of like having my name displayed when I'm playing a game. Hey, whether it's your real name or it's a made-up one, right? I want to say who's playing. So recognize that each time someone plays a game, their name might be different, or you might want to change your name during a game. So we want to use a variable to store what is the player's name. I think that we should have a variable called player. Well, in Python, all you do is just on a separate line, a separate instruction, type out the name of the variable. So type player, lowercase, P-L-A-Y-E-R. Now, we're about to do two separate things on one line of code. And it's actually pretty important to understand that there's two separate things going on and what those two things are. So far, we've done one thing. We have created a variable called player. Now, how does Python know that this is a variable? Well, it's actually pretty simple. It did the same thing that we talked about before. It started going through one character at a time, and each time it's looking up all of its Python instructions, and it's not finding that player is a Python instruction, and then it hits a space and goes, oh, okay, well, any series of characters followed by a space, that's the name of a new variable. Why? Because that's the way this Guido van Rossum guy designed his language. So we've made a variable. Now, what actually happens inside the computer? Remember I was talking about these memory devices inside the computer and how we've reserved some of those memory devices for our program? Well, that's actually occurred. This exact instruction on my line 3, what it does is it finds one location in memory device and it gives it a name. That name is player. We have a named location in a physical device inside your computer, and we gave it the name player. Now, here's the important part. There's no information in that space right now. It's just a named space. The best way I can think to illustrate it is that it's a bucket that can hold something. And on the outside of the bucket, it now says player. But there's nothing inside the bucket. There's no value inside there. There's no data inside it. So that's the second of the two things we're going to do on this single line of code. We're going to do what's called assigning a value to the variable. It just means putting something in the bucket. What's the data that's stored inside this variable? Well, the way you assign a value in Python is by using the equal symbol. So type an equal symbol and then hit space. Now, this equals symbol, remember how I said programming languages are made up of words and phrases and symbols? This is a symbol. This symbol means something very specific to Python. It doesn't mean anything related to math. It's not a math symbol right now. It means specifically whatever variable is on the left side of the equal symbol, assign a value to it, and you'll find the value to assign to the variable on the right-hand side of this symbol. So we need a value. Well, I want it to be the word Erik. So give me double quotes. You type your name, actually. Okay. And again, I know that's a very simple line of code, but there's some fundamentals about how computer programming works at play right in front of you. We have the creation of a variable, which means allocating a space inside the computer's memory device for that variable. And then we have the assigning of a value to that variable. They're two separate things. All right. I'm going to type out my whole name. Why? Because I want it to be different than what we printed before. So put your last name in there too. Because what we're going to do now is we're going to use that variable. Like if we run this right now, all that happens is we still just print our name over there. Well, now I want to print who the player is. So let's do a print again, P-R-I-N-T. And you do your parentheses because, again, the print command or print instruction needs some information. But we're not going to give it text information like we did up here. Instead, we're going to give it the variable. So type the name of your variable, player, P-L-A-Y-E-R, inside there. I'd like everybody in chat, before you run this, I want you, and here's a very precise question, I'd like everybody to listen to exactly what I'm going to say, or what I'm going to ask here. What exactly is going to appear on the right-hand side when I run this code? What exactly? Put it in chat. Someone says Erik Gross. That's actually wrong. Someone says Erik and Erik Gross, and that's right. There you go. Excellent. Now, for the person who said Erik Gross, totally understand. It's not like you're wrong, wrong, wrong with big capital letters. You were right in that we're going to take this variable and we're going to print the value inside that variable. You were absolutely right. But the specific question I asked is what exactly is going to print over on the other side? And what's going to print is first the word Erik and then Erik Gross. Now, why am I being a jerk about that? I'm trying not to be at all, right? It's this. When you start thinking with computers, it's important to think with literally the exact steps they're going to take and what exact output you expect. Now, again, we have a very trivial program in front of us. It has 3 instructions. There's not a lot of complexity here. But it is possible when you're working on very complex programs to make a change somewhere down inside the code and have it affect what happened earlier. That's way beyond the scope of what we're going to teach tonight at all, okay? But just know that that actually can occur. Changes in one part of the code can affect how other parts of your code work. And so I asked the question, again, not to be a jerk, but to get you thinking with something really, really important in programming, which is that programming is a constant back and forth of putting out a hypothesis or a guess about what's going to occur, and then doing your actual code, like running your code, and seeing whether what it did matches your hypothesis or matches your guess, back and forth, over and over and over again. And so having in mind an exact prediction of what's going to occur is vital. Now, again, this is a super simple example, so it isn't the best way to illustrate that, but I just want you to start thinking with this. All right, so we're now making use of variables. Well, let's say halfway through the game, I decided to change my name. Well, I'm going to change my name to Snoopy. I don't know. I just feel like it's Snoopy. How do you do that? Well, same way we did before. We just take player, go ahead and type this out, and we assign it. Remember, the equal is the assignment instruction. We assign a different value. Snoopy. So now print it out. Print player. And run it. And we are successfully using a variable. We're changing data while the computer program runs. And that change in the data is being reflected inside our computer program. Again, very simple example. Just want to give you an illustration of how that would work. That's what variables are all about. Something can change while the program is running. You need a way to keep track of that and use the now changed information or now changed data. Okay, good. So let's move on to one of these other 5 elements of a computer program. And that is control and branching. And by the way, introduce you to a thing called comments. In Python, if you do a hash symbol, anything after that is a comment. It doesn't change your code at all. You can put anything in here. You can go, we just showed how changing a variable value works. It's not going to do anything. Run the code, and it runs exactly the same way. These comments are in here to help you and other programmers who come along afterwards understand the code. And by the way, they really are for both you and others. Sometimes you'll go back to a program you haven't looked at in months or a year, and it's only because you left really good comments inside there that you're able to follow along quickly. And when you forgot to put comments, you're mad at yourself because it's hard to put yourself back where you were a year ago when you wrote that code. So those are comments. Well, now we'll do control and branching. So I actually want to erase all that, and we'll just do control and branching. That's what we're going to do next. So one of the primary things with control and branching is that there are two separate things. You have to have a way of controlling which of two or more available branches we're going to use. And then you have to have the branches themselves. So in Python, one of the control instructions is if, if, but you have to spell it right. So type if. Now, if is an instruction that needs some information. If we look up here, we have this print instruction that we've used a few times now. It needs information. It needs some content to print to the screen. But what if needs is very different. What it needs is a condition to check. A condition that can be either true or false. If it's true, we're going to do one thing, and if it's false, we're going to do another thing. So, since if needs information, we are going to use those open and close parentheses. But what we're going to put inside here is a condition. We're going to put something that can be evaluated by the computer, and it'll either be true or false. So, if we're dealing with this whole concept of, say, Python, one of the things that might be true is maybe they guessed correctly. Because you're going to guess over and over and over again, right? Well, we need to be able to determine, did we guess correctly? So, let's set that up. I want you to go back up right after the comment there, right above the if. I know we're not done with the if statement. But we need two things now. We need the actual word, and then we need the user's guess. So let's say we have a variable for holding the actual word, and we're going to call it actual. There, we made a variable. So type that out, actual. We made a variable. We need to assign it a value, and we're going to make it the word computer. But you should probably spell it correctly, unlike me. So that's the actual word we're trying to guess. Now, this next thing is going to be very simplified. The logic inside the actual Hangman game is going to be a bit more complex. But let's just say that the guess by the player was not the word computer. So we'll have a variable called guess. This is, what did the player actually guess? Again, this is a simplification. We need to assign it a value. And let's say they guessed apple. Now, again, it's not how Hangman works. I'm just trying to illustrate how you would set up a condition. We have two things here. We have what the actual word is we're trying to guess, and then we have what did the player actually guess. Now, you and I can look at this right now, and we know they're not equal. But we need to build our program in such a way that it can make the decision for us. Are these equal? So go back down inside those parentheses after the if. And here's how you set up a condition. There's a bunch of ways. We're going to show you the most common one, okay? You're going to have the two things that you're checking for whether they're equal side by side, and right in between them is a very special symbol. We're actually going to start with that symbol. So pay close attention to how I type this out. It's not how you would type it out after you've done a little bit of programming. I'm going to type it this way to illustrate how this whole little thing called a condition works. So inside those parentheses, where my cursor is right now, hit space. And I want you to type a symbol. It's two equal signs, one after the other, and then hit space. Now, two equal signs right next to each other is a very specific symbol to the Python programming language. Now, to you and I, it looks like somebody hit the equal sign twice. Why would you do that? You'd never do that in math. But this symbol means the following. If this symbol is inside of parentheses, then what Python is meant to do is look at a value to the left of the symbol and a value to the right and evaluate whether or not they're equal. So you could, for example, put the number 2 here. Sorry. Oh, I said the number 1 here and the number 1 there. Hey, those are equal. That's not what we're doing. So erase those. We are comparing the actual to the guess. So you can actually take the variables. Let's put the variable actual right here. Make sure that you're typing exactly as I am, with spaces and everything. And then we'll take the guess variable. We're almost done with our control instruction. We have an if, and we're giving a condition. We're giving a condition that the program is capable of evaluating for whether it's true or false. So now we need to produce a branch. What do we do if this condition is met? What do we do if the guess and the actual are equal? To do that in Python, at the end of the control instruction, you hit a colon and don't hit enter yet. We'll explain something. In Python, if you're setting up a branch, in other words, a set of instructions that will only occur if a specific condition is met. When you're setting up a branch, the way to designate that a set of instructions is that branch, that a set of instructions is the things that will occur only if the condition is met, the way you mark it out is you indent the instructions by 2 spaces. So when you hit enter, notice that our editor has already done that for us because it's a friendly editor. We are 2 spaces over. So any instruction we put here will only be performed if the condition is met. What do we want to do? Well, we want to tell them they won. So we're going to print, P-R-I-N-T, yay, you win. Like that. But what if it isn't true? We have another matching control instruction called else. But again, you should probably spell it correctly. This is the second branch. This is what we do if the condition is not met. Make sure you put the colon after it because same thing. We indent by 2 spaces, and the instructions that are indented by 2 spaces will only be performed if the condition is false. So let's print, sorry, you lose. So don't anybody run this. I'm going to ask the same question I did before. Put into chat the exact output you think we're going to get over on the right-hand side when we run this. What's the exact output you think we'll get? Erik Gross, Snoopy, and sorry you lose. Sonia, that's spot on. Let's run it. Erik Gross, Snoopy, sorry you lose. Good job. And we get the sorry you lose because in our control instruction, remember this if is a control instruction. In our control instruction, this condition was evaluated at that exact moment and it was false. Well, now, change the guess to computer. Run it again, and it says, yay, you win. That is a control and branching arrangement. We have a control instruction and one branch right here and another branch right here. I'm sure you can see how that mechanism would be super valuable inside computers. And most control and branching is that simple. You already know from your description of what the feature is supposed to be for the program, what the logic is. You just have to find a way to figure out, how do I test for the exact right condition? And once I can test for the exact right condition, what are the two different things that need to occur based on that condition? That's how control and branching works. All right, now, as you can imagine, we're going to need to check whether or not they got the correct guess over and over again. In fact, I think the way this particular game is built, I think you have 10 guesses. I have to look at the exact code. But here's the thing I'm going to ask you to look at is, if we were building this computer program and we had to over and over again ask the user for a letter, check whether or not the letter was in there or not, and then do something based on whether the letter was in the word or not, we would be writing the same instructions over and over and over and over again, 10 times. Well, this is a perfect opportunity for a subprogram. We want a subprogram that every time someone makes a guess, we can check whether or not they got the word right. In other words, we want this series of steps right here to be packaged up in a little subprogram, so that every time we need that 4 instructions to be executed, we can call on the subprogram and not have to type out all 4 lines again. And here's how you do that inside of Python. Let's go down to the bottom again. And by the way, these places where I've left empty lines, they don't actually change the way the program works. It's just for readability. So here's an empty line. There's an empty line. They don't change anything. We could remove those. The program would work the same. It's just for readability. So go down to the bottom, and we're going to make this thing called a subprogram. Now in Python, they're called functions. Same exact concept. It's a prepackaged set of instructions with a name. And you can, later on afterwards, you can call on that subprogram or this function. We're going to call our function, say, isMatch. Well, the way you make a function in Python is you use the instruction def. It means define. We're defining a function. And then you do a space. And what the def instruction needs after the space is, what's the name of this thing? You got to give me a name so that later on I can refer to the name. We're going to call it is, that's a capital I, and then match, capital M-A-T-C-H, isMatch. And then hit space. Doesn't have to be capitalized. I just happen to like capitalizing my functions. It makes it easier for me to read my code. And we can call it whatever we want. We can call it foobar. We can call it donut. Whatever you call it, you just have to use that name later on. But you want to choose a name that kind of reflects what the thing is going to do. We're going to check whether or not it is a match. Now, this part is pretty important. I shouldn't have hit a space afterwards, so go right back to after the H. Why? Because here's another important thing to think with in terms of these subprograms that we're going to build. And almost every computer programming language has something like this, so it is worth learning. When you're making a subprogram, we're going to call them functions in Python. But when you're making one of these functions, sometimes they need information in order to do their job. This particular function absolutely needs some information to do its job. It needs to be given the actual word we're trying to guess and whatever the current guess is. It needs those things in order to be able to check whether or not they're equal. Those things that you give to a function in order for it to do its job, they're called parameters. And we put them inside of parentheses. So give me an open and close parentheses. No space after the word isMatch. Inside here, you can list nothing, like no data needs to be given, or 10 different pieces of data need to be given. whatever your program needs. Well, we need two pieces of information. We need the actual, comma, space, and we need the guess. Those two things are needed by this function. So you put them inside these parentheses, and again, we call them parameters. So the two parameters that our isMatch function will take in are a variable called actual and a variable called guess. And then go to the end of that line and give me a colon. Now, you can probably guess what's going to happen when we hit enter. We're going to indent over by two spaces. Why? Because what's going to be indented, any instruction that's indented by two spaces, those are the instructions inside the function. Those are the things that will be performed if and only if we call on this function later. It's an important point. But we know what these instructions are. We can see them right above. So hit enter. Notice that our editor gave us the two spaces over to be friendly. And we know the logic. We need to do a control instruction, if. We need to take this value, this variable called actual, and we need to check, is it equal to this variable we have called guess? We took in this parameter. We took in these two parameters. Are the two parameters equal? And then we know what to do here. We have a control instruction. So you end it with a colon, hit enter, and now let's put a branch. Well, we know what it's going to be. Print. Yay! You win. Now, notice this is super important. We are still indented over by 4 spaces. Why? Because this instruction to print yay, you win is the branch to be done if this condition is met. Well, this next line, we're no longer putting in instructions to be done for that branch. So we need to go back twice and do our else. The else needs to be on the same level as the if. You see that right there? But then if you hit enter, we tab over 2 more spaces because now we're creating the second branch. And we know what it's supposed to be, your print. You see it above. Sorry, you lose. And then you can hit enter, and we're done with the function. So hit backspace a couple times. And I want to explain something about this function. First of all, I'll pause for a moment for everybody to look at it and make sure that their function is the same as mine. So, a couple things about this. Probably the most important thing. Actually, I'm going to ask you all. I'd like you to put into chat, same thing. Type out exactly what you think is going to appear over on the right-hand side when we run this. Each line that you think is going to print over on the right-hand side, list out each line. And by the way, if you want to do multiple lines inside one of these things, you have to use, I think, Control Enter, so it all stays within the same message. Someone take a stab at this. What do you? Sonia says, Erik Gross, Snoopy, yay, you win. Did anybody think that we'd see yay, you win twice? Because you're exactly right, Sonia. We won't. And if you've been paying attention, that's spot on. That's really sharp. It almost looks like, well, we're going to do this whole thing again right here. And Sonia's exactly right. We haven't called this function. And this is a super important thing to think with. When you see a function, doesn't matter what the language is, like I said, different languages, different programming languages, they call them different names, function or method, subroutine, subprogram. It's all the same concept. When you see a definition of a function, all you're looking at, this is critical, is a definition of potential behavior. These are things that could be done if we ask them to be done. All these other instructions above it are not that way. We're saying, hey, do this thing, Mr. Program. There's no conditions around it at all. This is totally different. A function says, at some point later on, if you happen to need these sets of instructions to be performed, they'll be performed if you ask, but I'm not going to do them until you ask. And yes, I'm being sarcastic, but knowing that difference can make code you read so much easier to understand. Well, let's use the function. Let's set up a whole different scenario. Let's say that the actual word is frog, but the guess is frog. Now, when I run this, is it going to say, sorry, you lose? Put your answer in chat. And when I run this, will it say, sorry, you lose as the last thing? Give me a yes or no. No one else can see your guesses. It'll be fine. I got a no. Anyone else? Well, let's find out. To call the function, all you do is print out the name of the function and then give it the data it needs. So the name of the function is match. So type that out. Don't hit a space. And inside parentheses, give it the information it needs. We'll give it the actual, and we'll give it the guess. Let's run it. And we do get the sorry you lose, because frog is not equal to frug. So the cool thing about this, I think you can see, is now every time we get a new guess from the player, we don't have to type out all of this logic. We simply call one line of code, give it the information it needs, and we get the functionality we need. And so, for example, if we wanted to change the message and have a silly emoticon in here, we only need to change it one place. And now every time we use that function, this change we just made is reflected. And again, we're dealing with an extremely simple program on the screen. I totally got it. I wanted to deliberately keep it simple to illustrate the fundamental concepts. But I hope you can see that last part, that if you've declared a function, oh, I put it in the wrong place. I didn't even put it in the function. Ah. Now let's run it. There's my emoticon. If you've declared a function and you need to change the way that work inside the function is done, you get to change it one place. And now everywhere you use the function takes advantage of whatever change you just made. All right. Now, let's look at the full code. I'm going to give you a link here. Let me drop this in to chat. I'd like everybody to pop open that code. And I want you to copy everything in there, like literally a Control A and a Control C. Sometimes if people drag their cursor, they miss a tiny bit of it. So copy all of it. Go back to your code editor. Erase everything in your code editor. And then paste in that new code. and then play the game for a minute. And then we're going to look through the code. Oh, whew. I won. Okay. All right. So let's look through this program and see a little bit of like, how does this stuff work? All right. So let's go to the very top. I want to explain the very first line because we didn't talk about this. Well, you can kind of tell from the color that import is a Python instruction. What this instruction does is it brings in what we call a library. A library is a set of pre-made functions. Someone else went and built a bunch of functions. In this case, they're all about generating random numbers so that you don't have to figure out how to generate random numbers. You can just make use of the code that someone else built. And so we're going to bring that library, those pre-made functions, into our program. And we're going to use them. You can actually see right down here that we're using that library. In fact, there's a function in that library called choice. You can even read that like, here's this variable called words. We assign the variable a value. It looks like the value is a collection of words. And then we're going to use from the random library a function called choice, and we give it all of the words. It looks like it's going to pick one of those words at random. So you can kind of see that. And all of that is inside a function. So I've got a function called choose word. Every time I call this function, it's going to return, it's going to give me one of these words chosen randomly. Okay, I can start to understand what this thing's doing. And then here's another function. It's called display hangman. And it's going to take in how many tries have we made. And it's got a variable called stages. And it looks like this is a weird collection. Look at this comma here. It's a collection of these funky images. Oh yeah, I've seen those images. They're over here on the right. So this just shows, I guess it's in reverse order, building the hanging body. So this variable holds the different stages of progressively not guessing the word right. Okay, all right, good. That's why we call this display hangman. I got it, okay. Oh, here's another function. This is a function called play. It takes in a word. Now, there's a lot of logic in here that we're not going to get deep into, but you can tell it's a function. You can tell we're creating variables. Lots of variables in here. We're doing some print statements. Okay. This is a control statement. While we haven't guessed the word, and we still have tries left, well then, have them guess a letter. Here's a control statement. If their guess is in our guess letters, sorry, you already guessed that letter. You could actually take your time and start reading through this and understand most of the logic of the Python game, of the Hangman game, just based on the 5 fundamental elements of any computer program that you learned tonight. Because there isn't anything else in here besides entrance point, variables, control and branching, and subprograms. And we don't even have to have a specific exit. It's one of the cool things about Python. As soon as it reaches the end of the file, the computer knows we're done. Now, I do want to make one kind of really interesting mark, which is Where is the first instruction? I said that in a lot of languages, the first instruction that's to be performed at the top of the page is what you do first. But what's weird about Python is the first instruction is right down here. I don't know if you noticed, everything above here is a function. This is the first time we actually call a function. Everything above here is defining functions. Main, play, display hangman, choose word. Those are all functions. We don't do any work until we reach the very bottom. And what do? Well, we call this function that we made called main. It's right here. Inside main, we call the choose word function. Then we call the play function. And we do that over and over again if they want to keep on playing. But you could actually trace through that logic yourself and start to make some sense of it. All right. Now, a fair bit of data. Don't go away. We've got more to cover and your free gift. But I want to give anybody an opportunity to get their questions answered. So, anybody got any questions right off the bat about anything we just covered? Does it matter when you indent on the lines of command? The indent only matters. You know what? It's a great question. Let's show you. Oh, it's not going to let me do that. All right, I'm going to delete it all. So let's do print hello world. And then we'll make a variable called name equals Erik. And we'll do a print name. Make sure everything runs. All right. Hello. All right. And then let's take this and we'll indent it. And run. There you go. So, yes, it absolutely matters where you indent. That's only true in Python. That's how Python tells whether or not you're in a branch is the indent. So it doesn't work. It would only work if we had some control function, a control instruction above it. That was a really good question. I like that. I actually really like what Maina asked. Let's go back to the way this code was before. There. So Maina says, brilliant question, right? Does import random not count as as the introductory statement? Yes, it does. It is the very first statement, okay? I'll tell you why as a programmer, I really wouldn't consider it to be such. While it might be the first thing that's actually being done, it's not the first point where we're doing any work. We're essentially just saying, hey, please just look at this code library. That's all we're really saying is look at this code library. We're not using any elements from that code library, the pre-made functions. We're not doing any work. So there would be nothing wrong if you had a very complex program to start at the top and read through, oh, what are we importing? It actually might be a smart idea because they might import 5 or 10 or 15 different libraries. And you start to get some insight into what kind of work are we doing inside here. So you are actually right. When I'm trying to figure out what's being done, the work that's occurring inside a program, I'll typically find what's the first instruction where we actually perform any work. And here, it's all the way at the bottom when we call the main function. Perfectly valid question, Maina. I really like that. Good. Any other questions? Absolutely. You're welcome. All right. Show you what's next. All right. So, like I said, stick around for your free gift. Just a quick word about the school, Okay, you've all been very, very good to stay this long. I hope you got something out of it. You're going to get something really cool out of our free gift. I just want to have a brief word about our programs. We have 12 coding boot camps, and they cover a wide range of subjects from artificial intelligence, which is kind of popular right now, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. We've covered all the major routes into technology and the different types of roles that are there. In fact, we have more certification programs than any other coding boot camp on earth, which we're kind of proud of. Here's what I want to tell you about how the boot camps are run. They're self-paced, yet they're also instructor supported. It means you can move at your own pace. They're flexible. Students set their own study schedule, and you can enroll 365 days a year. Our content is really well-rounded, really in-depth. The boot camps are affordable. Absolutely. We'll get to the recorded class link in a moment. Okay. The boot camps are affordable, the price under the national average. And this is key. Every one of these programs includes both job placement training and job placement assistance. More on that in a moment. Most importantly, though, they're designed for absolute beginners. You don't have to have any existing technology knowledge or coding experience, so you don't have to be a nerd to get through these programs. And who are these programs for? Anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities, better work-life balance, and it pays really well. So we consistently land on every major best coding bootcamp list out there. If you look at our average review rating across all major bootcamp review websites, we're at 4.8 out of 5 stars, and that's based on student and graduate feedback. So we do know what we're doing. Now, why would you consider working in technology? Some of these things you're already going to know, some of them are new, okay? It does have really good work-life balance. It's rare you're going to have a job where you're working 60, 70 hours a week and dealing with a really crappy boss and working weekends and all that kind of stuff. You don't see a lot of that in tech. And like I said before, remote work is very common nowadays, especially in the age of COVID. It's also a very creative industry. It's dynamic. There's a lot of communication and collaboration involving with other people, solving really fun, challenging problems. So you take a lot of personal pride in your work. And it's a stable industry that pays really well, and you keep on working and learning, and you'll get regular increases in pay. So there are barriers, though. There's three routes into tech: self-taught, colleges, and boot camps. There's barriers to doing a boot camp. The tuition can cost thousands of dollars, for example, right? We do have multiple financing options, including a big upfront discount and monthly payment options if you have a credit situation. There's options for anybody's financial condition. But the truth is, getting through a Tech Academy bootcamp is an investment in yourself. I firmly believe that. I've helped thousands of people break into tech and change their lives. Having that certainty and confidence in yourself and a skill set that'll last you for decades, that's a great investment. Now, there is a time investment. There's a fair bit to learn, right? Some boot camps run all of their training in what they call cohorts. You'll sign up, but you don't start right away. They gather together a bunch of people, and when they have enough people, they all start on the same day. And this is important. Everybody moves through the material at the same pace. I don't learn at the same pace as everybody else. Some things I do fast, and some things I do very slow. If it involves math, I'm probably going slower. So with our school, everything's online, so you don't have to go to a campus. We don't run by cohorts, and you can choose your own study schedule, which means part-time study is allowed. So you can study concurrently to holding down a job or whatever their other obligations you have. Finally, another barrier is there's got to be some technical interest or technical ability. I will say this. You may have gotten the idea that tech may not be for you because maybe the materials you're trying to study were too hard. It is not you. Some educators assume too much prior knowledge on the part of the student, and they make technology training materials inaccessible. I don't like that. We've designed our program so you don't have to be a nerd. You don't have to have any technology background to enroll. So I have some questions for you. Are you perhaps like working a dead-end job? Like there's an income ceiling that you know the most you'll ever make is not enough for you, or you're really unhappy with the way the job goes, or maybe even unemployed. Maybe you want to work from home. There's a work-life balance problem, or you want more time with your loved ones. The question is it time for a career change? And if it is, the Tech Academy can be the solution. We're career change experts. This bridge in our logo is there for a reason. We represent the route into technology for everyone, and we have over a decade of experience breaking people into technology. Most of our graduates make about $30 an hour on average in their first job. That's $60,000 a year. And you can move into that within a few months. And it's not isolated. We have over 1,000 graduates working in tech, everywhere from small businesses to really big companies like Nike or Facebook or Disney or Uber, Epic Games, right? So as a reminder, we have open enrollment. You can start anytime. So I encourage you to start now. Now, if you've ever seen one of our presentations, you've never seen this slide before because this is brand new. For students who enroll in April, well, we have 2 more days of this month, so those are included. But if you enroll in April, we have the 50% tuition discount for an upfront payment. We also, for upfront payments, will give you a refurbished laptop that you can use for the, just give it to you for your study, and it's yours to keep. There's no sales tax, no matter where you live. We'll also ship you every one of our publications, including our Intro to Coding books, Computers and Technology Simplified book, and our Technology Basics Dictionary to help you get through the program even more effectively. We'll also give you our brand new career planning guide. This is your blueprint for once you've graduated and you're working in tech, how do you plan out that next 6 months, 18 months, 3 years, so that you can attain your career goals? We've written a whole career planning guide for it. And we'll also give you 90 days free access to the Tech Academy Accelerator that I talked about earlier in the presentation. This is, again, especially like when you're really wanting to rapidly progress, deep dives into technology concepts. Look, I'm not an arrogant guy, so it feels really weird saying this, but you get access to me, and I've been doing this for 40 years, and I love helping people. And so inside that accelerator, you get undiluted Erik. Some people like that, some people don't, right? But you get 90 days free access to the accelerator, and this part is huge. You'll get unlimited job placement from our job placement specialists until you land your first job. If you're willing to keep working hard at it, we will never let you down. You keep on working with our job placement folks so you can get hired. And we've never put anything like this together. Jack and I have been working on it for about a month on how is this going to look. And so for anyone who enrolls in April, you're going to get all of these things. Can't guarantee how long it'll go because we're trying this out, but you're going to have all those things if you sign up in April. So how do you do it? Well, you go right here to the Erik link. I hope I do this right because I didn't have an assistant. Here's my excuse. Yeah, if you go to learncodinganywhere.com/Erik, it's right in chat, okay? And just apply. When you fill in the form, it's a really simple form. There's a series of steps afterwards that'll tell you all about the Tech Academy. There's videos, articles. There's even a way to book a call with one of our admissions personnel and get your questions answered. So if you want to take a moment and sign up for that form, that's great. Don't worry about doing all the steps. Just sign up for the form. And then in a moment, I'll have your gift and also links on where you can find the recordings of these classes, including this class. Wow, I need more water. Yeah, I want to put that back up there because it's just huge. Nope. How do I do it? There it is. Yeah, those, I can't believe we're giving all this stuff away. It's only for April. All right. One quick thing, by the way, referrals have always been a really, really huge source of enrollments for us. And so years ago, we started giving 5% commission payments for all referrals. And you can do that too. It's not just for our students and graduates. So in a moment, I'm going to have you email in if you want to get the free gift. And if you have someone you want to refer to us, you can include their name and contact data in there. And if they sign up, we'll instantly cut you a check for 5% of the tuition. I mentioned books. I want to clarify. We have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a Technology Basics Dictionary, a Project Management Handbook, and You Are Not Stupid. You're Not Stupid, by the way, is phenomenal, and it's one of the things that we're giving our new enrollments in April. It's basically a written version of our computer basics course, the most popular course in our whole boot camp, right? It explains all modern technology terms and concepts. It's got a history of technology, so you understand how we even arrived where we are today. You Are Not Stupid is the book I wish had been written. I wanted to be written for years. No one did, so Jack and I wrote it. It's really, really good. All right, so the free gift. We wrote, again, Learn Coding Basics in Hours with Python. It's a physical book. It's really good, and we will give you one for free. Actually send it to your house. Now, unfortunately, this is for US only, but if you want to copy this and you live in America, then I'm going to give you this email right here. I'm going to put it into chat. You can see it on the screen. Just send us an email and include in there your name and your mailing address. We'll ship a book out to you right away. This it's a really good, it goes into a lot more detail even on the 5 fundamental elements of any computer program. It takes you all the way through all the syntax, all the different words and symbols of Python. There's a lot inside that book, and it's yours for free. Also, if you have people to refer or you have any further questions, you can drop them in there. Questions always get forwarded to me. So I'll wait 1 minute for anybody who wants to grab that and send us an email. And then I'll talk to you about the links on where to find everything. All right, so we made it really easy to get all of the links about our school. We use this service that you may have heard of called Linktree. I'll put the link in the chat. Okay. You're going to find everything you probably could want about the school there. Links to our free educational YouTube video playlist. This video will be uploaded there within a day, so you can watch the whole thing again if you want, right? You'll find links to our books, our dictionary, our upcoming meetups. If you want to come to future classes, they're always listed up there on Linktree, right? You have links to our social media accounts as well. So please follow us on social media, invite your friends to future meetups, and tag us. And even if you want a free copy of You Are Not Stupid, by the way, we give one away every week for free. All you have to do to get in the running for that, like we pick the name out of a hat, to get your name in the hat, just share a link to the next event on your social media and tag us. It just helps spread the word. If you'll do that, we keep track of everybody who does that. And every week we pull a name out of a hat and we send them a copy of You Are Not Stupid. And again, you can find those links at the Linktree. Well, thank you so much for attending. I super appreciate it. If you filled out the form, right, at this link you see on the screen, if you filled that form out, when we're done here, go back in and finish those steps. Watch the videos, read the articles, inform yourself about who and what we are and what we do and how our programs work. You'll be glad you did, right? And I'd love to see you at our next event and see you in the accelerator. And I thank you all so much for attending. And I really appreciate all the questions as we were going through. Y'all are great.